Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshops and exercises to learn about AWS services. Recently, AWS announced that now you can create a Lambda function which can have container image as a runtime. And today I'm going to talk about how you can create a Lambda function which will have container-based runtime. And this feature was recently announced during the reInvent time. So let's get started. So what exactly is container-based Lambda? So if you look at a typical Lambda function, what you do, in the Lambda function, you select a runtime, and your runtime could be like .NET Core or Go or Java or Python. So you select a runtime. So this becomes your runtime environment for your Lambda function, and then you write your function handler. That's how you create a typical Lambda function. If you try to build, if you talk about a container-based Lambda function, the fundamental remains the same, but the runtime changes. In this case, you can have a container-based image as your runtime. And since you can have a container-based image as a runtime, you can create any kind of customization, any kind of packaging inside your container image. So the primary difference is, in a typical Lambda function, your runtime is or you can say a runtime is a provided runtime by AWS, where you can select between your Python, Ruby, Java, or .NET, those options. In this case, you can bring your own runtime. Think that way. So you can create your own container image, bring your own runtime, and on top of that runtime, you can run your function handler just the way you run a function handler in a normal Lambda function. So it's pretty straightforward. The primary difference is that in case of a container-based Lambda function, you can bring your container image as a runtime. So why we need this container-based Lambda function? And the reason is that sometimes your runtime is so customized. It is like you need to have a base image, and then you want to deploy various kind of packages on those images. So sometimes you have highly customized runtime requirement, and in that case you can. I'm showing one example over here. Like for instance, suppose you're using a .NET Core based runtime. In that case, you can have a .NET Core based image, and then you can have your custom packages deployed on top of that. So you can really create a highly customized runtime. And then on top of that, you can create a Lambda function which can use your highly customized runtime, and the custom packages you have deployed on your runtime. So you want to go for a container-based Lambda function only if these out-of-box runtime are not able to give you the required it's not able to fit your requirement, and you need to create your own container-based customized image as a runtime in order to run the Lambda function. Okay, so how do we configure a container-based Lambda function? So the starting point is a Docker file, because first you need to create a container image. And in order to create the container image, you configure a Docker file. In this Docker file, you of course you you put your script, you put your commands to bring your runtime, your packages, your dependency for your runtime. Okay, so it's a typical container, it's like typical Docker file, like you create any containerized image and you create your Docker file. Same way, create the Docker file here as well. And in a Docker file, you bring your runtime packages dependency, plus you also write your Lambda function handler. Okay, so that also, so in this case, like in a journal Lambda function, you select your predefined runtime, and then you can upload your Lambda function handler code to it. In this case, in the Docker file itself, you need to have your runtime packages dependency plus your Lambda function handler. Both has to be packaged in the same image. Okay, so that way your development is little different, because when you're creating your container image, at the same time you're also writing your Lambda function and making that Lambda function handler, or baking that Lambda function handler as a part of the image. And once you configure this Docker file, then you can convert this into a Docker image. Okay, then you can upload this Docker image to some registry. It could be Elastic Container Registry from AWS, or it could be any other image registry as well. But you need to upload it to a registry. Then all you need to do is create a Lambda function which simply refers to this Docker file. Or this Docker image. Okay, so you simply create a Lambda function. You say, okay, this Lambda function I am creating out of one image, and then you simply mention this image name, and that's it. And then you can launch your Lambda function. I'm anyway going to show you an exercise at the end of this video, and then you can see how exactly you configure, and that also you can use to get some hands-on practice of your own. Okay, so this image is very important thing, because this image is going to have your runtime environment. It's also going to have your function handler. So this image has a specific requirement. You cannot use just any image. So this image needs to have a runtime interface client. Okay, and this interface client is important, because this actually creates a communication between Lambda and your function code. Okay, so you simply cannot go and use any image. Your image needs to have this runtime interface client baked as a part of the image. Now, how can you do this? There are two ways. One way is that AWS provides a number of base images. And these images are actually provided in different runtime requirements like Node.js, Python, Java, .NET, Ruby, Go, you choose it. So AWS provides some base images. You can use these base images. And the beautiful part of these base images is that it has a runtime interface client already baked into it. So you can simply take this base image, and on top of that, you simply add your customized packages which you want to add to this image, and simply use that into your Lambda function. Very simple. But if you don't want to do that, you can use some alternate base image as well. Okay, you can use any alternate base image, but in that case, you have to add interface, runtime interface client. So when you're adding your customized packages to your base image before you create the final image, you also add a runtime interface client for into this base image. You bake this interface into the base image. And again, AWS provides these runtime interface client packages for all these languages from Node.js to .NET, Go, Ruby, Python, etc. So basically, you have two choices. Because of this runtime interface client dependency or compulsion inside the base image, you can either use AWS provided base image, or you use your own base image, but you have to add this runtime interface client here. Okay. Now this image which you have simply used, actually you can do certain configuration into it. And this is typically the 4 configuration you can do is that you can provide an entry point, which could be your absolute path for your entry to the application, the entry path to application. You can put a command parameters, and that says how do you want to run it? How do you want to run it when your Lambda function starts? Okay. Then you can set up your working directory, and of course you can set up your environment variables. Now, what is the use of these settings? I mean, to be very honest, you can create an image where you don't need to configure any of such things. I mean, you can simply configure your image and then simply use it. And you don't need to set up any entry point command or working directory. You can make it very much part of your image itself. Okay. Well, you can do that, but sometimes people want to create an image which is reusable. And in that case, they want to parameterize these entry points, commands, working directory, those kind of things. In that case, you can create a generic image where these settings are parameterized, not hard-coded. And in that way, your image can be used by more than one places in different kind of settings. Okay. So that's the use of these settings. These are optional settings, but they are very important if you're trying to create a reusable image for your Lambda functions. There are certain constraints and limits you should know. Few already exist in earlier and few are new, but you should know actually. So for instance, image type. This container-based image should not be more than 10 GB. Yeah. So maximum image size allowed is 10 GB, not more than that. It supports only Linux-based container image. So at least at this point of time. So suppose you want to use any other kind of runtime other than Linux, it is not possible. Then some specifications from Docker image point of view, it should supports manifest v2 schema 2, and then OCI specs 1.0.0 onwards. So these are the certain things you should be careful about from the image type point of view. Now, from the developer tool point of view, due to support for this, Docker image manifest v2 or OCI 1.0.0 onwards, you should use only those container or developer tools which support these two schemas and specifications. So yeah, that's pretty straightforward. In Lambda function, you know that in a generic Lambda function, you have got a temporary directory access where you can store a local file up to 512 MB. That is still possible, by the way, and it is still 512 MB. Just because you're using a Docker image or container image, it's not going to increase or decrease. So you still have access to temp directory, and that is capped at 512 MB. And that's on the constraint or limitation parts. So what we are going to build today is that we will create a container image. And then we'll upload that to Amazon Elastic container registry. And then we'll launch a Lambda function using this container-based image. And then we are going to test it. Okay. In order to do this exercise, we have created a workshop. And this workshop is published to our website, aws-dojo.com. I'm going to walk you through the steps of the workshop, but this workshop provides like your line-by-line instructions. You can simply follow the instructions to create a Lambda function, which is using container as the runtime. So without wasting any more time, let's go over there. So this is my website, aws-dojo.com, where we have published this workshop. Let's start the workshop. So these are the steps you need to perform to complete the workshop. Let's start with the first step. The first step is pretty straightforward. You need to have an AWS account in order to complete this exercise or workshop. If you don't have AWS account, you might want to click on this link to create the AWS account, trial account. Then we create an ECR repository. Since we are going to create a Docker image and we need to store this Docker image somewhere so that Lambda function can simply use the Docker image from that registry. So for that, first we create a repository. So we go to Elastic Container Service and say, go to repository, say I want to create an repository. And then you say I'm creating a private repository. You can create public as well. But I'm creating a private repository in this case. And then we provide a repo name. And then we create the repository. And we also investigate the push command, because these commands you are going to use in order to push the image into the repository. So our repository is ready. It's called Dojo repo. So next step is to actually create a Cloud9 environment. And why I'm creating a Cloud9 environment here? Because we need a box, a development environment somewhere where we can create the container based container image or Docker image. So for that, we are using a Cloud9 environment. So we go to the Cloud9 environment, say we want to create a new environment, give this a nice name. Then we are selecting the smallest machine, which is T2 micro. So it is free tier releasable. Then we select Ubuntu as the operating environment. Once our environment is up and running, we try to update the system. So we first update the repositories, then we install Docker. Generally, Cloud9 environment comes with a Docker install, but we are simply installing it to make sure that it's there. So we install the Docker, then we start and enable the Docker, and then we check the Docker version to make sure that Docker is up and running. So Docker is up and running on this machine. Now we can create the container image. So in order to do the container image, if you remember I discussed earlier that when you're creating a Docker file needs to have the runtime, dependencies, and plus it also needs to have your handler code. So first I'm creating the handler code. So you see here in the Cloud9 environment, you create something called app.py file, and then simply put a handler code. And look at this. I mean, this is the same handler code like you write into any other Lambda function. So no difference over there. So this is a Python handler code. And all we are doing here is simply saying that, hey, you reached the container runtime. So we are keeping it pretty straightforward. And then what we do, then we create a Docker file. In this Docker file, what we are doing is that we are again keeping it very simple, just so that you do it this one very fast. So what we're doing is we are using one of the Python images shared by AWS. So as I discussed earlier, that AWS provides certain runtimes. Okay, Python is one of the runtimes which also so these images also have your runtime client install. So I simply using that base image provided by AWS. Then and then I'm creating my final image. In final image, I want to add my app.python, my handler file, to this var task folder where this folder has to be, and then we're simply starting the app handler. Simple. Yeah. So our Docker file is ready. It's a simple one. Then we start creating the Docker image and then start uploading it to our ECR registry. And for that, I will use the push commands, which we saw in the earlier steps. So first step is to simply log into our repository. We log into our repository, then we build our image. You can see in this case, and then we simply tag our image or label our image, and finally we push our image. So these 4 commands we do so that this whole image is published to our repository. Now you can see here it is published to the repository. It's pretty straightforward and simple image, 173 MB. Okay. Now my image is ready. Now I can create a Lambda function based on this image. So for that, we go to Lambda Management Console. There you have to select the option called container image option. So on the top, it shows you a couple of options. So you have to select the container image options. Then we give this Lambda function a name. In this case, we're calling it Dojo function. Then container image URI. So here you can use this browse button actually to, if you're using ECR as an image repository, so you can use the browse button to simply provide the location to the image in your ECR registry. But if you're using, say, external image, then you have to provide the URI for the image over here. Here you can override the image settings like this work directory and command and entry point, those things. But in this case, we are not doing it. It's pretty straightforward for us. And then we are simply using the basic Lambda permissions, and we create the function. The function gets created. Now we have to test it. So we are simply creating, click on the test to create a new test event. We have given we call it, say, Dojo test, and we gave some input, but basically input is not required because we are not consuming the input in the handler file. And then we simply run this test. And when you run the test, you can see a response back saying that you reached to the container runtime. That means the Lambda function has run and it is using your container-based image to actually execute the function. And then that's it. Then the next step is to go and clean up the resources so that you don't incur any cost post the workshop. So that was all for this workshop, guys. Hope you like it, and please click on the like button if you like it. Please subscribe to my channel. There are many other similar workshops and exercises which you can learn to get hands-on experience about AWS services and also learn about AWS services in that. So please do explore this website. We always look forward to your feedback, whether it is for new content or any mistakes I'm doing or any issues you want to discuss. So always look forward to your feedback and comments on that. You can provide those feedback or comments either in the comment section of the YouTube channel, or you can also click on the contact us tab over here to provide the feedback. So I always look forward to your feedback. And I promise to come back again in a couple of days' time with another video and tutorial. In the meantime, stay safe and have a nice day. Bye-bye.